Hey everyone, my name is Joseph Thomas and congrats on making it to this part of the SMLC course. This section is going to focus on decision tree classifiers. With that, let's start with a basic rundown of the topics that are going to be covered. First up, we will discuss a basic introduction to decision trees as well as the terms and definitions that are also associated with this particular algorithm. We will then go over the algorithms for splitting such as Gini impurity and information gain. We will then discuss random forest as well as ensemble learning and conclude with an implementation and visualization of decision trees. Most importantly, get ready for the final assessment where you can test yourself with an implementation on Titanic data. As mentioned earlier, we are first going to be starting with the terminology and definitions that are associated with decision trees. A decision tree is simply a tree-like model of decisions. It's also a supervised learning algorithm that can solve both classification and regression problems. The overall goal of a decision tree is to create a model that predicts a sample's class or value based on rules derived from previous training data. Here's a basic example of a decision tree from Wikipedia that shows survival passengers on the Titanic and the various futures the algorithm selects and how it reaches its final decisions. For reference, the SIBSP term refers to the number of spouses or siblings on board. In the next video, we will dive into how the decision tree chooses what futures to use and how it actually splits. Now let's go over some basic terms. First up is the node. The root node is going to split into subnodes, and those subnodes are going to split into more subnodes. This process continues until a final decision is actually made. Each of those subnodes and the root node itself are all considered nodes. Next up is the root node, which is simply the first node that represents a sample being used in a particular decision tree. The process of splitting is what actually creates nodes. Nodes are divided into two or more subnodes beginning from the root node. We will go into much more detail about splitting in the next video. The leaf or terminal node is the end of a node where the node cannot be split anymore. It's also when the outcome or decision is actually showed and made. In pruning, the overall goal is to reduce the complexity and prevent overfitting in a decision tree. In pruning, essentially, sometimes new examples that are classified, for example, with a decision tree, will rarely reach a terminal node, meaning that the algorithm has overfitted or adapted solely to the training data. The process of pruning is able to get rid of those redundant and useless parts of a decision tree. We won't be going over pruning too much in this part of the course, but it's overall a critical part to decision trees and overall machine learning when it comes to reducing overfitting. Next is a branch or a subtree, which is a subsection of a decision tree. The term parent and child node refer to a node that is divided into subnodes. That node that is divided is considered the parent of those subnodes. Those subnodes are the child of that parent node. The next two terms refer to the purity of the node. A 100% pure node occurs when all data in a node belongs to a certain class. In contrast, a 100% impure node occurs when a node is split evenly in a 50-50 division. In a 50-50 division, the information actually gained is not very significant, making the goal an overall 100% pure node to ensure the decisions can be most clear and beneficial, making a proper final outcome. These are a basic list of the terms that are going to be critical throughout the rest of this part of the course when we discuss decision trees. Thank you for listening to this short first part of this session, and I hope to see you in the next video as well.